Today we will be talking about different ways of separating the components that are mixed together, physically mixed together. These techniques are just based on physical properties and no chemical processes are involved. Methods that we will discuss today are filtration, crystallization, simple and fractional distillation, chromatography, and the choice of solvent for the separation of substances. We know that a solution is formed when solute is dissolved in a solvent. The solute may get dissolved to give you a clear solution. Like this is a clear solution because you can see through it. And you can get a clear solution if you dissolve sugar or salt in water. But if you dissolve sand or chalk in water, it won't dissolve and will form a cloudy mixture. So mixtures contain one or more substances just mixed together, not chemically combined. For example, air is a mixture of different gases. So this is an example of cloudy mixture. Alright, so let's begin with the first method of separating insoluble solid from a liquid like sand or chalk dissolved in water. It is easy to separate by filtering it. Chalk or sand will be trapped in the filter paper and water will pass through it. The trapped solid in the filter paper is called residue and the water is called filtrate. Evaporation. To obtain salt from an aqueous solution, what should we do? We can heat the solution to evaporate water. When very little water will be left behind, salt will start to appear. You just have to heat it carefully until you get dry salt deposited in the evaporating dish. Crystallization. Crystallization is also a method to obtain solids from their solution. Some solids have impurities and are less soluble at low temperatures like copper sulphate. So we can carry out crystallization. But first we have to make their saturated solution. But what is a saturated solution? You can take a beaker or a glass, fill it with water and add some sugar into it. You can stir it because it will help you dissolve sugar easily. But if you continue adding more and more sugar, eventually no more of it will dissolve, even if you stir it hard. The extra sugar will settle at the bottom, and now this is called a saturated solution. So a saturated solution has been formed. So once the saturated solution is made, then the saturated solution is heated to evaporate some water so that it becomes more concentrated. Now if you let it cool down, the crystals will start forming in it as the temperature falls. And now you can filter out the pure crystals and rinse them with distilled water and dry them on the filter paper. In this figure, you can see that there are two ways by which a solute can be obtained from its solution. The two methods are evaporation and crystallization. So, a solute can be obtained from its solution by these two methods, but we have to decide that which method do we have to follow. Like crystallization works well for those substances that are less soluble and they crystallize out when the temperature falls down and their concentrated solution is cooled down. But for solids like salt, the effect of temperature on solubility is less. So It can be separated simply by evaporation, as evaporation is much an easier process as compared with crystallization, which takes a lot of time. Now, if you have a mixture of two solids, like a mixture of sand and salt, to separate, how can it be done? You should think of a solvent that can dissolve any one of the component. Like you can take water in this case. Water will dissolve only the salt, but sand will not dissolve in water. So now you can just filter it to separate sand on the filter paper as residue, and then evaporate water and you will get the dry salt. But if the mixture is of sugar and salt that you have to separate, then what would you do? Because both sugar and salt, they are both soluble in water. Now you should think of changing the solvent. So instead of water, you can use ethanol, because ethanol is a solvent that can only dissolve sugar, but salt will not dissolve in ethanol. But remember one thing, that ethanol is flammable, so do not put it directly on the burner. It should be evaporated over a water bath. You can see the picture of the water bath. Now, simple distillation. Simple distillation is done to obtain solvent from its solution. For example, to obtain water from its salt solution, the salt is taken in a round bottom flask. So this is the round bottom flask, and we have taken salt solution inside it. The round bottom flask is fixed with a thermometer and a condenser. Condenser is an apparatus which is used to cool down the vapors. Round bottom flask containing the salt solution is heated, and the temperature will rise in the thermometer till it reaches to 100 degrees Celsius. And you know that 100 degrees Celsius is the boiling point of water. So boiling point of water is equal to 100 degrees Celsius. So what will happen, that water will start boiling at 100 degrees Celsius, and its vapors will rise and will come in the condenser where they will be cooled down. How? Because you can see that there is water circulating in the outer jacket of the condenser. You can see water coming in and moving along the condenser, and moving out from the other side, like this. So water vapor will rise in the round bottom flask, and from the round bottom flask the vapor will come in the condenser where they will be cooled down, because there is water continuously moving in the condenser. So as the vapors will be cooled down, they will change into water droplets. Now these water droplets will drip in the receiving flask as distillate. So finally we have separated water from its salt solution. Many countries are obtaining drinking water from seawater in distillation plants. Fractional distillation. This is used to separate a mixture of liquids from each other due to the difference in their boiling points. Different liquids have different boiling points. Actually, all pure substances have their fixed and sharp melting and boiling points. So if you have a mixture of water and alcohol that we have to separate, since both are liquids, we cannot separate them easily. So what can we do? We make use of their difference in their boiling points. The boiling point of alcohol is 78 degrees Celsius, right? So the boiling point of alcohol like ethanol, that is equal to 78 degrees Celsius, and the boiling point of water is 100 degrees Celsius. Remember that all the pure substances have their fixed and sharp melting and boiling points. So what have we taken in the round bottom flask? We have taken a mixture of water and ethanol. Again we will heat the round bottom flask. As the temperature rises, ethanol and water will start evaporating. Both the water and ethanol will start evaporating over here in the round bottom flask, but you know that ethanol is more volatile than water, so it will vaporize more and will start boiling when the temperature goes to 78 degrees Celsius. Now, in this case, the round bottom flask is connected with a fractionating column. A fractionating column is a glass tube filled with these glass beads. So a mixture of more ethanol vapors along with some water vapor will rise in the fractionating column. Both the vapors will condense on the glass beads, making them hot. When the beads reach about 78 degrees Celsius, ethanol will distill out at its boiling point, and the water vapor will condense and fall back as water droplets in the round bottom flask, like this. The ethanol vapors will rise up, they will go in the condenser where they will be cooled down and liquefy. Finally, the droplets of ethanol will be collected, they'll fall down in the receiving flask, and the water droplets will cool down over here. Since the temperature is only 78 degrees Celsius, at this temperature water droplets will water vapor will condense and change into water droplets, that will fall back into the round bottom flask. The temperature in the thermometer will stay at 78 degrees Celsius for some time. After all the ethanol gets distilled out, then the temperature will start rising above 78 degrees Celsius, showing that all the ethanol has gone and only water is left behind in the round bottom flask. So now you can stop heating and the separation is done. Fractional distillation is important in producing ethanol in petroleum industry to refine crude oil into petroleum and some other components or hydrocarbons, and to separate the mixture and to separate the gases which are present in air. Here you can see fractional distillation of crude oil to get different hydrocarbons or components having different boiling points. All the components are separated on the basis of their boiling point. The lighter components are those with lower boiling points and less masses. These will come out first, like for example gases will distill out first, and the heavier components will distill over at high temperatures. And for the fractional distillation of air, first the air has to be liquefied, so The air is compressed and cooled down to liquid air at minus 200 degrees Celsius. Then it goes into the fractional distillation column where it is warmed. The temperature will rise from minus 200 degrees Celsius to minus 190 degrees Celsius, and at that temperature nitrogen gas will distill out. Then the temperature will rise again till minus 185 degrees Celsius. At that temperature, oxygen will move out. So the process of separation occurs due to the differences in their boiling points. Chromatography. Paper chromatography. This method can be used to separate a mixture of substances. For example, if you want to find out how many dyes are present in black ink. So first we have to take a strip of filter paper and draw a line with the pencil on one side, which is called origin or the starting line over here. Then we put a drop of black ink in the center, like here, and then let it dry. Then we hang it in a solvent which is taken in a chromatographic jar. This is a chromatographic jar. Now the solvent you can take water or alcohol, but you have to be careful that the ink spot should be above the level of solvent. Like the spot should be here, above the level of the solvent. Otherwise, you will not get the separation done. So just hang the filter paper for some time and then the solvent will rise up the filter paper due to capillary action. Now as the solvent moves over the filter paper, different colors get separated and you get 2 or 3 spots on the filter paper. This filter paper is now called chromatogram. So this is a chromatogram. With the separation of different colors like red, purple and blue. And this line is called the solvent front. So solvent front is the distance traveled by the solvent from the baseline or from the origin. This line is marked as solvent front. So now we have to find out the distance traveled by each color spot. For that, always measure it from the original line till the spot. Actually, dyes in the ink have different solubilities in water, so they travel at different rates. The most soluble one travels faster along with water, that is why they separate. So here they have taken the reading from the baseline till the spot. For red, the distance covered by the red ink is 2 centimeters. The distance covered from the baseline till the purple spot is 6 centimeters, and the distance covered by the blue spot is 8 centimeter. And the distance traveled, the level till the solvent rises, is called solvent front, which is 10 centimeters in this case. Sometimes in this case the spots are colored, but sometimes the separation is done and we don't get colored spots. So for converting colorless substances or colorless spots to colored ones, a locating agent is sprayed on the chromatogram. This helps to locate the position of the colorless substances. For example, locating agent ninhydrin is used in detecting the presence of amino acids. Now, this is RF is called the retention factor. And retention factor helps in the identification of substances, and it's equal to the distance traveled by the solute divided by the distance traveled by the solvent. So let's calculate the RF value for the red ink or for the red spot, for the purple one, or and then for the blue ink. The distance traveled by the red ink is 2 centimeter, so it will be 2 centimeter divided by distance traveled by the solvent. How much is it? It is 10 centimeters. So your answer would be 0.2, and remember, no units since it's a ratio of two distances. Purple spot, it would be 6 centimeters divided by 10. Answer would be 0.6. And for the blue spot, it would be 8 divided by 10, so 0.8. So that is how we calculate the RF value for different components. Chromatography is a technique which is used to identify or check the purity of a substance, or to separate mixture of substances that may be colored or colorless, and to purify a substance by separating it from its impurities. Now let's summarize what we have learned so far about the different methods of separation. First, we studied filtration. So filtration is done to separate a solid from liquid. A solid can be chalk from liquid, chalk dissolved in water. Crystallization and evaporation. These two methods are used to separate solute from its solution. For example, salt solution or salt plus water. Here we separate the salt, whereas in simple distillation the solvent is separated from its solution. For example, here again we take salt solution or salt dissolved in water, but the difference is that here we separate water, or we distill out water and remove salt from it, whereas in frictional distillation the different liquids are mixed together and they are separated from each other. In paper chromatography, different substances are separated from a solution. Thank you for watching. Please subscribe, like, share and comment.